Hi folks, Mr. Long here. I'm going to do a quick screencast. Well, it'll be longer than normal actually. Screencast of the ambiguous case. It's a pretty complex topic, so I thought it's probably best if I go through an example, as you've already suffered through a couple regular classes with this, and this way you can look at it, rewind it, view parts that you don't understand. So you'll get questions like this. Solve a triangle, and it gives you a few measurements, an angle of 30 degrees, a side length across from that angle of 10, and then another side of 16. So what we've got here clearly is a case of side angle given, and that's when the ambiguous case applies. Whenever you have a side and a side and an angle given. In particular because there's one angle and side across from each other. So let's start by drawing a triangle that would fit this description. What I tend to do when I draw them is draw them as if the ambiguous case would work. So I know that this is A, and so that's 30 degrees there. And then across from A is side A, which is 10. And then we have side B. And what I would always do is make whatever's given, so the two upper sides, I would have those as your numbered sides, the given sides. And that makes this B, that's A, and then this becomes right here, the 16 is side length B, and then we have angle C and side C. So the big idea here is that, so you've got a side, followed by a side, followed by an angle. So in order, right? Side, then a side right beside it, then an angle. And that's why side, angle are given. And normally in this case, you would use the sine law, and we will begin with the sine law. But there's a scenario here where it's possible to get two triangles. And so what we do is I would right away draw and say to myself, is it possible to have a second triangle? And I know that from our investigations that we've done, if I had a second triangle, it would look like this. 10, 16, 30. It has the exact same measurements in the same locations, but the triangle is very different. Clearly what's significantly different is the length of side C and the other two angles. Okay, so that's the other triangle that might be possible. Now, since this 10 is less than 16, it's plausible. In other words, it's possible that we've got two triangles, but we have to do a bit of math to make sure. So let's go ahead and do that. The first thing we always want to do in this case is figure out what angle B is. And I need to figure out that missing angle right here. And I'm going to do that with the sine law. And in this case, I'm solving for an angle. So the angles go in the numerator in my equation. And the sine law always works with pairs. So there's a pair right there, an angle side pair, like opposite side, opposite angle. So it's the 30 degrees and the A. So it's sine of 30 divided by a side length of 10, and the other one is the sine of angle B divided by 16. So we multiply both sides by 16. Sine of B equals 16 sine 30 all over 10. And I've got that. And what I want to do here is solve for angle B. And so I do this, I'll put this in the calculator, folks, and do it all at once. So 16 times sine 30 divided by 10, all in one calculation. And you're going to get that sine B equals 0.8. And then, just like if you had x squared equals 0.8, you'd have to square root both sides. We have to sine inverse both sides. So B equals sine inverse of 0.8. Angle B then equals, I'm just going to round to the nearest degree, 53 degrees. So I'm going to move on to the next page where I can do a few more calculations. So we got angle B to equal 53 degrees. So that means that angle right there is 53 degrees. Now the question is it possible to have two triangles? And so here's what we do. We take this side right here and we make an isosceles triangle inside the larger triangle. And what you'll notice is that this side right here is exactly the same as this side over here, right? I'm seeing if it's possible. So since it's an isosceles triangle, this is 10 right here, right, where I'm highlighting, then what that means is this little angle here is 53 degrees as well. Well, is it possible that this angle from here to here is 53 if this angle's 30? And I think the answer is pretty clear, yes, because the angle right here for this little triangle to actually exist must be steeper than this 30, right? If you just follow the logic of it. So this angle here is steeper than this. So the answer to this is yes, two triangles are possible. And in fact, it's possible because 53 degrees is greater than 30 degrees. So what is the angle right here inside? What is that angle? Well, it'll be 180 minus 53 because it's a straight angle. So that's 127 degrees. So I can go over to the other one and I know that the angle right here is the same as the angle right here. So that makes this angle right here 127 degrees. Okay, so I've got that. So I know my two triangles. I know I know there's two triangles. Oh, by the way, at any time I can get the missing angle up here now because I have 2 out of the 3 angles and they sum to 180. So you can do that at any time. You can get the missing angle there and the missing angle there. Okay, but now we need to figure out the side lengths. We know there's two triangles. We know the angles. Let's figure out the side lengths. So we're going to solve for side C. We're going to do that with the cosine law. Normally with the cosine law, what you do is you have a contained angle right here. And it's, by the way, it's S side, angle side. So 16 would be known, 30 degrees would be known, X would be known, so it would be a number. And this would be your unknown over here for the cosine law. And that's how you'd use it. Side, angle, side given. But what we can do is we can actually have a variable as one of the containing sides or the adjacent sides and solve for it. We're going to get a quadratic equation. But that makes perfect sense because we've got two lengths to solve for, and a quadratic can generate two solutions. So we have x here, we have x here. We're going to generate both solutions. So here's our formula, right? And it's always the number that goes at the start of the equation and the angle are the same. And then the other letters are simply the other two sides, the containing sides. So let's go ahead and do this. So I'm going to use all the thing about this is you must use the original information given. So you're not going to use angle B in this case, the one we just calculated. It's the original information given. So I've got a squared, in my case, is 10 squared equals 16 squared plus x squared minus 2 times 16 times x times cosine of 30. So, and I'm just going to go through this on the calculator to show you. I need to do 2 times 16 times cos 30. Actually, you know what? I think you can do that. Just do 2 times 16 times cos 30. And it'd be really good if you had your calculator out as you did this, just to verify my calculations. I don't know. You don't need to really write this down because you can go back and look at it, but it'd be good to do the calculations. So if what I'm going to do is isolate everything on the left side. So I'm going to have to take this 10 squared and subtract it from both sides. And you might be used to saying bring it over to the right side. So I'm going to have to collect like terms there. So I'm going to end up with 16 squared minus 10 squared, which is, this is 256, that's 100. And then I'm going to have to multiply this out. So I'll write that out as if I've simplified it. So it's going to end up with 0 equals x squared minus 27.71x. And 27.71, by the way, is 2 times 16 times cos of 30 plus 156. 156 is just 16 squared minus 10 squared, or 256 minus 100. Now that's a quadratic equation. I have to just use the quadratic formula and solve that. So I've already prepared this one. So what we've got here, folks, is there's my quadratic equation I need to solve. And remember it's a, so there's the a value, which is 1. The b value, which is, including the negative 27.71. And the c value is positive 156. A, B, C. And in the quadratic formula, the way that I do it, you don't have to do it this way. And again, I would go through this calculation, but I always calculate the discriminant first, which is equal to b squared minus 4ac. In our case, b is negative 27.71. I'm going to square that. And then it's 4 times a. In this case, a is 1 and c is 156. So then what I'm going to do is figure out what the discriminant is, and that actual number works out to 143.84. I'm going to square root that because that's part of the formula, which is 11.99. And now I substitute into the quadratic formula, which is the zeros, z1 and z2, are negative b plus or minus the square root of the discriminant divided by 2a. And so what I did, I've just separated that out into the positive one and the negative one. Okay, so I'll just move on to the next page and actually carry out the calculations. So what it will be is Z1 will then be, and please make sure you pause it, go back and things and look at it. So that's going to be 27.71, because that's the negative of B, right? And B is negative 27.71, plus 11.99, and that's divided by 2a, and a is 1, so that's 2. So Z1 is 19.85. Z2 is 27.71 minus 11.99, because I have the plus and minus case, divided by 2. So Z2 is then 7.86. Now we can actually draw our triangles. So I've got this triangle here, which is 30 degrees, 10, 16, and this worked out to be 53 degrees, and then this side will be the longer of the two sides, 19.85. Then the other triangle is the ambiguous triangle, and it's also 30, 16, and 10, but this time it's 7.86 in length, and that angle there is 180 minus 53, or 127 degrees. And then we can figure out those two missing angles right there by simply by subtracting, in this case, 30 and 53 from 180, or 30 and 127. So that's the ambiguous case of the sine law, folks, where you get two complete triangles. Remember that solving for a triangle means you solve for all unknown sides and angles. I would encourage you to go back over this again. There is no doubt in my mind that you're going to get an ambiguous case question on your unit test, so it's probably worthwhile to know this process.